section 4.3, and we're going to talk about properties of logarithms. And we're going to use a lot of the properties in the next section, so we're going to make sure that we understand these properties. And these properties, we talked about the product rule, and we talked about exponent. The product rule for logarithm, the product rule says that the logarithm of product is the sum of the logarithms. So here in example 1, we have a logarithm of a product. A product means multiplication, so here's the product. Then we can change it to the sum, so this would be the log base 4 of 7 plus the log of base 4, 5. This is part A. Okay, so in part B, we have the log of a product. Here's the product right here. And again, we don't have the base written here, but we assume the base right here is 10. We have log base 10, 10, plus the log base 10 of x. Again, we're not writing that 10 down here or here because it's assumed to be 10. Now, if you look carefully, this right here, the log of base 10, 10, that's the same thing as 1. So I have 1 plus the log of x. Okay, that's something we learned in the last section. Log base 10 of 10, well, 10 the first power is 10. Okay. So some students ask me, well, how do I know this is true? Let me give you a little mini proof. If I have the log of base 2, 8 times 4, according to this, the same thing as log base 2 of 8 plus the log base 2, 4. Well, this right here would be equal to 3, because 2 to the third power is 8. So I get 3 plus, this would equal 2, because 2 to the second power is 4. So I get 2, and I get 5. But if I had gone and done the product here, excuse me, and said the same thing as the log base 2 of 32, well, isn't that the same thing as 5? 2 to the fifth power is 32. Okay, so I get the same answer if I had done it this way or this way. The quotient rule says the logarithm of quotient is the difference of a logarithm. So here I have a logarithm of a quotient. So now I'm going to do the difference of the logarithms. So this is going to be log base 7 of 19 minus log base 7x. Excuse me. Then part B, I have a logarithm of quotient, the same thing as a natural log of e to the third power minus the natural log of 7. Now this right here can be evaluated, simplified further. E is the base here, so e to what power gives me e cubed? Well, that's just 3. So 3 minus the natural log of 7. The power rule says, this is what we're using a lot in the next section, if you have a logarithm of a number with an exponent, well here it is the product of the exponent and the logarithm of that number. So what we're basically going to do, we're going to take this p or this exponent and bring it out to the front and make it a product. So use the power rule to expand each logarithmic expression. So in part A, I have log base 5, 7 to the fourth power. Well, this one had this logarithm of a number with an exponent. This 4 can come out to the front. It now becomes 4 log base 5, 7. Okay, in part B, there's no exponent here, but this is the natural log of the square root of x. That same thing as the natural log of x to the 1/2 power. So that square root, remember we talked about in the P chapter, is the square root is the same thing as the exponent of 1/2. And now I can bring this 1/2 out to the front, so I get equals 1/2 the natural log of x. Okay. And last one in part C, I have the logarithm of a number. This is the number right here with an exponent. This 5 can come out. So I have 5 log 4x. Okay, so on your own, and here's the summary. Let's go ahead and do the summary real quick. If I have the natural or the log of base b of a product, the same thing as the log base b of m plus the log of base bn, sum. And then for number 2, if I have the logarithm of a quotient, that's going to be the log base b of m minus the log base b of n. And then in part C, or I keep saying C, number 3, here we have logarithm of something with an exponent, of a number with an exponent. You can bring that p out here, that's log base b m. That's the summary of what we just did in the other page. So on your own, go ahead and do the next few problems on this page, and go ahead and use the the property of the rule for logarithmic expressions, and then go ahead and pause the video, and then I'll restart the video and check your answers. Okay, so on your own problem, the first one you should get log base 6, 7 plus log base 6, 11. Part B, I get log 100 plus the log of x, and this right here is the same thing as 2 because 10, which is our understood base here, to the second power is 100. In number 2a, you should get log base 8, 23 minus log base 8x. Part B, you should have the natural log of e minus the natural log of 11. And this is the same thing as 1 because e to the first power is 1. And I get the natural log of 11, the minus the natural log of 11. Number 3 is the product rule. I'm going to go ahead and bring that 9 out to the front. So I get 9 log base 6, 3. And in part B, the square root sign is, the radical sign is not all the way over there, so I'm going to fix that. This is the same thing as the natural log of x to the third power because it's the cube root. And I bring that 1/3 out to the front. I get 1/3 natural log x. And then here I have the log of this with a exponent on it. So I bring the 2 out to the front, and then I have the log of this. Make sure you keep that in parentheses. Now a lot of students want to separate this and put log x plus log 4. You can't do that. This is not a product here. Okay, so it's a sum. Okay, example 4, let's go ahead and use the same properties to expand each logarithm as much as possible. So in part A, I have log base b of the quantity x squared square root y. Okay. The first thing I'm going to do is I'm going to go ahead and use the product rule. Here's the product right here. So I have log base b x squared plus the log base b square root of y. That was the product rule. Now I can go ahead and within here I can use the power rule and bring the 2 out to the front. So I have 2 log base b x, and here I have, this is the same thing as y to the 1/2, so I'm going to say y to the 1/2. So now I can bring the 1/2 out to the front, so I get plus 1/2 log base b y. Okay, so some students will rewrite this as log base b y to the 1/2. Now, if you're in my class, I would emphasize how important it is to make this b a subscript. So make sure when you write this, log base b, this b is down here, and you have y to the 1/2. Okay, it's hard for me to read and understand what's going on if you have log b, y to the 1/2. I'm not sure if that b is a subscript, so make sure it's below the word log and it's smaller. Okay? And that would be the end of that example, or part A. Let's do part B. And so I have right here, I'm going to use the quotient rule because I have a logarithm of quotient. So now I have log base 6 cube root of x minus log base 6 36 y to the 4th. So over here, I can go ahead and write this as log base 6 x to the 1/3 power minus, and here I'm going to be really careful. Right here I can use the product rule because 36 times y to the 4th, but I want to make sure I subtract the entire product, so I'm going to move in parentheses. So I have log base 6 of 36 plus log base 6 y to the 4th. I hope you understand why I need parentheses here. I come subtract this entire thing here. So whatever this is right here, when I convert it, I have to subtract the entire thing. That's why I have parentheses right there. Now this over here, I can write 1/3 log base 6x. Now here I have minus, and if I look inside the parentheses, here I have, this is the same thing as 2, because 6 to the second power is 36. So I get 2 plus, and then here I can bring the 4 out front, so I get plus 4 log base 6 y. Okay, and I'm going to go ahead and distribute this 2, or the minus sign. I have 1/3 log base 6 x minus 2 minus 4 log base 6 y. Okay, so on your own, go ahead and pause the video, and on your own, go ahead and do the next 2 problems, and pause the video, and then check your answer as soon as you're done. Okay, so here are the answers to the on your own problems, and over here I went ahead and use the product right here, and make sure to put parentheses here, I use the power rule here, and here I use the distributed first, and then I use the power rule here. So as long as you get this answer, 1/2 log base 5x minus 2 minus 3 log base 5y, you're good. Okay, let's go into how to condense logarithm expressions. So let's go backwards. What if I give you a logarithm and I'm adding on to the logarithm of the same base? You can go ahead and condense those to using the product rule. If you have log same base and you have a subtraction problem, you can do the quotient rule. And if you have a factor on the outside of a logarithm, you can make that power by doing the power rule backwards. Okay. So now we're going to condense them. So right here I have this. I have log base 4, here's log base 4, and there's a sum there. They're the same base. I can go ahead and change that to a product. I get log base 4 of 2 times 32, which is log base 4 of 64, which is the same thing as 3, because 4 to the third power is 64. Here I have log, and these are both base 10 because there's no base indicated. And the subtraction, so I can go ahead and write quotient there, and I get log of 4x minus 3 all over x. And you don't have to have the parentheses there, or you could do it without the parentheses. The log of 4x minus 3 over x. Okay. On your own, go ahead and write these as a single logarithm, and go and pause the video and then check your answer. Okay, so here are the answers. You have log 100 when you go ahead and use the product rule, and then you get 2 because 10 second power is 2. And here I use the quotient rule, so I have log of 7x plus 6 over x. Here's a very important thing to remember. Coefficients of logarithms must be 1 before you can condense them using the quotient and product rules. For example, to condense this, the coefficient of the first term must be 1. So look at this term right here, and notice how this coefficient is a 2. You want to make that a 1. The first thing you want to do is you're going to go ahead and take this 2 and put it on the x. It becomes the natural log of x squared. So now the coefficient here is 1. The coefficient of the first term must be 1, and that's what I have right here. But now I have the sum, so I can now make this the product rule. So I have the natural log of x squared times x plus 1. Okay. Let's go ahead and start. I don't think I have time to do that next example, so I'm going to stop the video here, and then the next part we'll start example 6.